Welcome back to Mr. Hassan's Maths channel. I'm going to answer question number 14 from the October 2019 International A-Level Core Mathematics C34 paper. This question is about parametric equations, and this would be included, I'd guess, in the P4 work. In the P4 work that in the new syllabus, this would be under P4. Okay. So the curve C1 has parametric equations x equals t squared minus 1 and y equals t cubed minus t, where t is an element of the real numbers. The line L is the normal to the curve C1 at the point where t equals 2. Show that an equation of L is 4x plus 11y minus 78 equals 0. Okay, so basically what they want us to do is to find the equation of the normal to the curve, to this curve at the point where t equals 2, and show that that becomes this equation over here. Okay, so now to find the equation of a normal is a straight line which just is perpendicular to the tangent of a curve. So if you have a curve, for example, that looks something like this, and you draw a tangent to the curve, the tangent to a curve is also a straight line, but it just touches the curve and doesn't pass through it. Okay, it just touches the curve. It has the same gradient of the curve at the point at which is the tangent, and the normal to a curve is basically perpendicular to the tangent. Okay, so the gradient of the tangent and the gradient of the normal are perpendicular. So what we're trying to find is the equation of the normal to the curve at the point where t equals 2. So this is not, of course, a sketch of this curve. I just randomly drew something. Just imagine this is where t equals 2. That's the point where t equals 2. What we need to do to find the equation of the normal is we need to find the gradient of the curve at t equals 2, and then the gradient of the normal will be perpendicular to that, so it will be the negative reciprocal of the gradient of the tangent to the curve at t equals 2, and then we can find the equation of the normal. Because to find the equation of a straight line, we need two things. We need the gradient, okay, which we can find once we found the gradient of the curve at that point, and we need a point on the line. Okay, so we need a point on the line, and we can find the point on the line where we can find what it is when t equals 2, because that's the point where this is the normal to it. So first of all, let's go for the point in the line. So we know the point that we're looking for is when t equals 2. Okay, where t equals 2, the x coordinate is going to be, we've got t squared minus 1, so you're going to have 2 squared minus 1, which is 4 minus 1, which is 3. So x equals 3, and y equals t cubed minus t. So y is going to be 2 cubed minus 2. So that's going to be 8 minus 2, which is 6. So the point that we're looking for is the point 3, 6. So we got the point 3, 6, and now we have to find the gradient of the normal. Okay, to find the gradient of a line, we need to find dy dx. Okay, to find the gradient, we need to find dy dx. Now, we have the equation in terms of a parametric form. So we can't find dy dx easily by making this into Cartesian form, expressing y in terms of x. But what I can do is I can use the chain rule, and I can say that dy dx is equal to, because I can find what dy dt is, dy dt times dt dx. That will give me dy dx. Okay, so first of all, I've got to find what dy dt is and what dx dt is. So I know y equals t cubed minus t. So dy dt is going to be 3t squared minus 1. I know x is equal to t squared minus 1. So dx dt is 2t. So we can say that dy dx is equal to dy dt, which is 3t squared minus 1, multiplied by the t dx, which is the reciprocal of this. So it's like multiplying by 1 over 2t, which will give us 1 over 2t, which I can just write as this. Okay, so now I can see that the gradient of the tangent to the curve is going to be, when t equals 2, at the point where t equals 2, is going to be 3 times 2 squared minus 1 over 2 times 2. which is going to give me 3 times 4, which is 12, minus 1, which is 11, over 4. So the gradient of the tangent is equal to 11 over 4. Therefore, is 11 over 4. Therefore, the gradient of the normal to the curve is its negative reciprocal. So now I know the point on the line is 3, 6, as we worked out, and the gradient of the line is minus 4 over 11. So I can use y minus y1 equals m times x minus x1, and I can go ahead and find the equation of the line, and hopefully it will turn out to be exactly what they want us to show it's going to be. So let's see. We have y minus the y coordinate, which is 6, equals m, which is minus 4 over 11 times x minus the x coordinate, which is 3. Multiply both sides by 11 to get rid of the fraction. So I have 11y minus 66, and expand this bracket. We've already got rid of the 11, so we've got minus 4x plus minus 4 times 3 is 12. Bring everything to one side, so add 4x to both sides. You'll have 4x plus 11y. Then you've got minus 66 minus 12, which is minus 78 equals 0. And I think that is as we required to show. 4x plus 11y minus 78 equals 0. 4x plus 11y minus 78 equals 0. 4x plus 11y minus 78 equals 0. So that's exactly as we're required to show. And that's how we tackled the question part A. Okay, so that's part A done. Now for part B. Now part B tells us that the curve C2, it's a different curve, has a parametric equation x equals 12.5 plus a cosine t, and y equals 15 plus a sine t, where a is a constant and t is between 0 and 2 pi. Find the range of values of a for which the curve C2 does not cross or touch the line L. Okay, so the line L is the same line that we found the equation for in the last question. Okay, so basically we got to find the range of values of a such that this line does not touch or cross this curve. Okay, so this seems like a bit of a strange type of question, but let's just soldier ahead. Now basically what I have to try to do is to try to find a solution to these two equations parametrically. I'm going to first find how to solve these parametrically to see where they do cross and do touch. Okay, so that then after that we can then decide the values of a for which it won't occur. So basically what I'm going to do is I'm going to try to solve these simultaneously. When you have a Cartesian equation and a parametric equation and you want to solve them simultaneously, what you can do is you can take the value of x and y from the Cartesian equation and substitute them into the parametric equation. So instead of 4 times x, instead of 4x, I'll replace the x with what it's equal to from the parametric equation. So it's 4 times 12.5 plus a times the cosine of t. And then I've got plus 11y, so plus 11 times, instead of y, I'll replace it with 15 plus a sine t. Minus 78 equals 0. So I've got to try to basically find the values of a which will make this equation have no solutions, for which there will be no solution. So right now we're kind of like working blindly. You don't really know exactly how this will pan out, but let's just soldier on with what we know. There's nothing else really we can do apart from just carry on. Okay, so let me multiply 4 by 12.5. That's 48 plus 2, which is 50. And 4 by a cosine t, which is 4 times a cosine t. And 11 times 15, which I think is 165. Okay, that's 10 times 15, which is 150, plus 1 times 15, which is 50, yes, that's 165, plus 11 a times sine t minus 78 equals 0. So let's just simplify this a little bit. We've got 50 plus 165, that's 215. 215 minus 78, let me just go back to my trusty calculator. So we're going to have here, where were we? 50 plus 165 minus 78, and that gives us 137. So I'll have 4a cosine t plus 11a sine t, you can say equals minus, what was it? Minus 137, because I've just, it was a positive 137, I've subtracted that from both sides to get an equation that looks like this. So I've got to find the values of a such that this will have no solutions. Okay, now I can I've got an idea now what to do, because this is like something of the form like, you know, p cosine of x plus q sine of x, all right, something like this, which you can write in the form r cosine x plus alpha. All right, because I basically, if I can express this in the form of a single trig ratio, then I know that I'll have something in terms of a times the cosine of an angle equals minus 137, and I've got to find the value of a for which that will have no solution. And I can think about the graph, the cosine curve, and think about it such that it will have no solutions if it never gets below, if it never reaches minus 137 on the y-axis. That's what I have to try to think about. So I can see I can rewrite this in terms of a single trig ratio, and I'm sure I can use it in terms of cosine, because we have the compound angle formula, which is the cosine of a plus b, and we have the other one, cosine of a minus b. I think this is the one that's going to work, because when you split this up, you get cosine a cosine b plus sine a sine b, and here you have a cosine first and then a sine. So if I rewrite this in terms of, let me take this part now and rewrite this in terms of, so I'm going to take 4a cosine t plus 11a sine t, and I'm going to rewrite this in terms of r times a, and I'll say cosine t minus alpha. Okay, and then I can try to find what the value of r is, and then I can solve this problem. And I'll be able to think about it in terms of the graph. So let me just take this. You have r a cosine t minus alpha, which will give me r times a times cosine t, okay, cosine alpha, and I'll have plus r a sine t sine alpha, because we know that this splits up into cosine a cosine b plus sine a sine b. We've got that in our formula book. Okay, it's called the addition formula. So I know that this will split up into that, and I know that that has to be the same as 4a cosine t plus 11a sine t. Now what I can do is I can compare the coefficients of each of these sides. So here I have cosine t multiplied by ra cosine alpha, and here I have cosine t multiplied by 4a. Okay, and in the second one I have here, I have sine t multiplied by sine alpha and ra, and sine t here multiplied by 11a. So what I can do here is I can say that the ra cosine alpha must be the same as 4a, because they're both multiplied by cosine t. So I can say ra cosine alpha is equal to 4a, because these are identical, and the coefficient of cosine t must be equal to be the quotient. It must be equal to the coefficient of cosine t on the other side, and the coefficient of sine t on one side of this identity, which is ra sine alpha, must be the same as the coefficient of sine t on the other side, which is equal to 11a. Okay, so from here I can find what r is, because I can cancel out the a's, okay, from both sides of this, and I can say basically I know that cosine alpha is equal to 4 over r, and sine alpha is equal to 11 over r, So I can think about a right angle triangle. I can think about this as alpha. The cosine of alpha is 4 over r, and the sine of alpha is 11 over r. So therefore I can work out what r is. R is going to be the square root of 11 squared plus 4 squared. So r is going to equal 11 squared, which is 121, plus 4 squared, which is 16. That gives you 137. Okay, so it's like, seems like something familiar. 137 was, okay, it was this same value here. Okay, so that's interesting. That looks like it's working out nicely. So basically what I can do now, instead of writing 4a cosine t plus 11a sine t equals minus 137, I can replace the 4a, I can replace it in this form basically. I can replace this with something in this form. I know r now is root 137. So I can say a times the square root of 137 times the cosine of t minus alpha is equal to minus 137. This is the equation now that I have formed. Okay, this is the equation that I have formed from equating or from solving the parametric equation of the normal to the curve and the curve itself. All right, the normal to the other curve. Okay, normal to the curve that we found in the first equation, to equating this to this, basically finding out where they intersect. So they will intersect, okay, at values of they will intersect basically when this is equal to minus 137. So we've got to find the value of a such that they will never intersect. We want to find the values of a for which the curve and the line will never intersect. So this equation tells us when they do intersect. So I've got to think of a value of a which will cause there to be no solution. Okay, so now if you think about this, if I just rearrange this equation a little bit, I'll have a times cosine of t minus alpha equals minus 137 divided by root 37, which will give you minus root of 137. Okay, if I divided 137, okay, by the root, or by minus the root of 137, okay, that will give me minus root 137. Okay, all right, so now this will have a solution, because remember this is like the cosine curve, cosine t minus alpha. Okay, it will have a solution, okay, when the cosine curve, see, this is a times cosine of something, so this a will cause the cosine curve to stretch. So this is going to be t minus alpha, so it's going to go ahead somewhere, but basically the highest value it reaches depends on a. So if a becomes, for example, 3, this will go as high as 3. When a equals 3, this will go as high as 3. And if a is equal to 3, it will go as low as minus 3. Okay, so we want to find the value or values of a such that this curve will not ever get as low as minus root 137. So it can't reach minus root of 137. That means the value of a has to be less than minus root 137, and also it has to be no, not less than, sorry, it has to be greater than. Okay, because if a was less than minus 137, it's going to get lower than that. Okay, so it's going to go even lower than this. So it has to be greater than minus root 137, and it has to be less than the square root of 137. Because if you have a root 137 there, it's going to go as high as root 137, and it's going to go as low as minus root of 137. Okay, so if it's equal to root 137, it will touch this line. It will touch the line. So it says where the curve and this line will never touch or cross, yeah. So basically it will touch if you have the value here as of minus root 137, okay, and if it's lower than that, it's going to in fact cross, so it has to be higher than minus 1 root 37, okay. So, and also, you know, if I make the value of a positive root 137, okay, then what's going to happen is I'm going to have see, if it was negative 1 root 37, it's just going to be like upside down, but it will still reach the same lowest value and the same highest value of minus 1 root 37 and plus 1 root 37. So the cosine curve, which is got a positive coefficient, will go like this, for example, between 0 and 2 pi. But if it has a negative coefficient, it will just go like this instead. But it will still reach the same highest and lowest value if the magnitude of that coefficient is still the same. So basically, our value of a has to be between minus root 137 and root 137. Okay, it can't be equal to them. If it's equal to them, it will touch. If it's greater than the square root of the square root of 137, it will actually go over on that side and on this side. So therefore, it will have a solution for this. Okay, if it's like if the value of root 130, if the value is greater than this, it's going to go over the curve, and if the value is less than this, it will also go over and cut through or touch the line minus root 137. So a has to be between these two values. Okay, so that's one way of dealing with this question here. Okay, another way I guess you could deal with it is you could say that the cosine of t minus alpha is equal to minus root 137 over a, and you could say, okay, this will only have a solution, okay, because we know that the cosine of an angle has to be between minus 1 and 1. So we could say that minus 1 root 37 over a has to be between the values of minus 1 and 1. Otherwise, you won't get any solution. Okay, you won't get any solution because this has to be between the values of minus 1 and 1. So we have two inequalities here. I'll just carry on over here just to show. We've got one inequality is that minus 1 is less than minus root 37, minus 1 over root 37, and the other one is minus 137 over a is less than 1. Okay, so over a. So now I can multiply both sides by a, and I'll have minus a is less than minus 137. That means a must be less than root 137, and I've got here minus root 137 is less than a. Okay, so I can say here that a must be greater than minus 1 root 37. So a is less than that and a is greater than that. That's one way of solving these inequalities. Okay, however, I think it's easier for us to think about it in the way that we did it over here. Okay, up here, just by thinking about the graph, that you know that the value of a for this to have no solutions has to be less than root 137 and more than minus 1 root 37, so that it never reaches this value. Okay, because this is like the stretch factor for the cosine curve, and whatever value this is, that will be whatever the magnitude of this is, that will be the highest value it reaches and the lowest value it reaches. And so if the magnitude of this a is the same as root 137, then it's going to be touching the curve, and if the magnitude of this is bigger than the square root of 137, then it's going to actually cut through the curve as well. All right, so therefore the magnitude of a has to be less than basically the square root of the square root of 137. Okay, if the magnitude of a has to be less than this, then we can say a must be between minus this value and positive of this value. This little thing here has a few little issues because of the minus signs and multiplying by a being minus and stuff, so I would kind of ignore that part, to be honest. All right, it's better to think about it in terms of what I mentioned here. Okay, so we know that the magnitude of a has to be less than root 137 for there to be no solutions, so that the curve doesn't reach as low as minus 1 root 37. Okay, so that's the answer to that question. Okay, I went on a bit there, but that is a bit of a tough question, I'd say, and it's kind of like, I guess it's worthy of being the last question on a C34 paper. Okay, normally those are the tougher questions, so you have to think a little bit here. It's not an ordinary question. Part A was pretty much straightforward, okay, but part B you have to think a little bit and think a bit out of the box. It's not a normal type of question. You would normally associate a question like this with something to do with like discriminant, okay, but here we have a trig function. There's probably other ways to solve it as well, but this is the way that came into my mind when I saw this form here. So I can rewrite it in this form, and I know the range of this function. You can tell the range of a function when it's in this form here, because the range is going to be whatever the magnitude of this is, the negative and positive of that. Okay, so here we worked out that the range has to be between plus and minus root 137. Okay, so that is the answer to this question. Thank you for watching, and if you would like to see other questions to do with C34 papers, you can, or other questions from this particular paper, when I get around to answer them, you'll find them on this playlist that should appear over here. Other questions to do with parametric equations from P4 and C34 you can find over here, and you can subscribe to my channel from this link, and other papers to do with maybe P4, P3, C34. I'll put a card at the top for you to watch other stuff. Thank you for watching. I hope you understood, and see you soon.